Welcome to part 3 video on compounding pharmaceutical gels. Now in this presentation, by now you should have watched part 1 and part 2. In this presentation, we're guided by the references shown on the slide. And we are going to look at sample formulations and a basic method for how they should be compounded and the techniques that the textbook really does not tell you, but over the years we have kind of understood the principles and we're guided by accuracy and how to minimize transfer loss. So some of the techniques that will be mentioned in this video, if you should look at the references, they just give you a basic method. Now, let's review very quickly what you'll find in the formulations coming up. In the formulations, you're going to see a gelling agent. We're doing water-based jellies. There should be a drug that we're incorporating. And by now, we should appreciate that we have wetting agents that may serve as co-solvents or solvents to dissolve our active ingredients, but that's not the focus of this presentation. We're more using these in the context of being wetting agents to help disperse our jellies. Preservatives are a big part of jellies, and of course, some examples that were given on previous presentations. Presentation 2, again for emphasis here, you may see methylparaben or propylparaben. Chlorhexidine gluconate is also a preservative. Some jellies may need a stabilizer, but not the formulations I'm going to show you. Now, calculation alert. Some calculations may require you to make your own stock. For example, if the formulation called for 70% alcohol and we only have 90, please review calculations for how to make your own stock of alcohol. I may very well do a video on that. But some drugs may not be weighable based on the equipment you have. And so making solid in liquid triturates may be required. And so this is also something that you need to brush up on. Making solid in liquid triturate is a whole technique by itself and will not be covered in this video. When we make our liquid, solid in liquid triturate, we remove an aliquot that will be carrying the desired quantity of drug that we need or preservative. Now, how do we basically make our jelly base? Yes, the base is the big thing. And so hydration of the jelly and incorporating the preservative in the jelly base is really what is crucial. You do not want to make your jelly base, add your drug, and then in the last of it all, remember you need preservative. The jelly base is going to swell and thicken with time, and so it's important to incorporate the preservative in this early phase so that as the jelly expands and hydrates, the preservative expands and hydrates with it as well. So we do not want, when we're making jellies, to have a very thick jelly base and then pouring in our preservative. No. Jellies are predominantly water-based, and so the preservative need to be a part of the jelly base. We then add our drug effectively, whether soluble or insoluble, and of course, if we're mixing, recover all contents as much as possible from the stirring device, because most jellies in our compounding lab will be making by weight. Yes, making by weight is important, so you want to recover anything from the stirring device that you're using. Now, if you watch some videos on YouTube, you do have balances, analytical balances that have a stirrer component, and so you could actually drop a stirrer, a magnetic stirrer in the beaker so that you can stir without using a stirring device to remove any of your product. Now, the first one we're looking at is jelly using gelatin. Now, these are real old formulation, but they're delivering a principle. And so the principle is what we're looking at. Gelatin is light amber. It may come as sheets. And so if you read the procedure in some books, it tells you that you have to cut the gelatin into pieces. But what we are working with in our labs are the flakes or the granules, which are already finely reduced. We do not size reduce gelatin. That's a very wrong procedure. No procedure should be saying you size reduce gelatin. No. You cut into smaller pieces or you hydrate the granules themselves. Now, gelatin importantly swells and hydrates with cold water. So during the hydration process, you do not want to use hot water. Let's get cracking. So the first formulation is zinc gelatin jelly. It's a real old formulation, right? But again, demonstrating the principle of how you make your jelly base, which is made up of gelatin, glycerin, and water. And for this recipe, it would add up to, I think that's 85 grams, right? And so you need to know the weight of your beaker. And so that's what you're aiming for. You made the weight, you made the base by weight. And once you have verified the weight of the base, you then add in the zinc oxide and stir for uniformity. This has to be a quick process because this can turn gummy bear. Have you ever bought those vitamins in store and chew those gummy bears? Yes, gelatin. The product is going to come out actually like a gummy bear. So it's going to take the shape of the mold that you're going to pour it into. So working efficiently is important because you don't want the mixture to get cold on you and the mixture solidifies. So let's go. You want to sieve your zinc oxide. Yes, it's a fine powder, but you sieve it and weigh your 15 grams. So this procedure is if you're making a 100-gram mixture. Record the weight of the crucible or the beaker. We're going to use beaker. We're going to use beaker in the lab, okay? I find over the years that the beaker is a longer wall. The crucible is more open, and so the product dries up faster in the crucible. The beaker somewhat makes it solidify a little bit more, but the beaker has longer walls, so when you're pouring, it can actually harden in mid-air on you. And so both of them have their pros and their cons. So we're going to use a medium-sized beaker for this. Wet the base of the beaker with a small amount of room temperature water. This is important because you're now going to sprinkle the gelatin. So about a ml or two of water. You're going to add the gelatin to the base of the beaker and spread it out. There should be no heap or mountain, okay? No hill. So it should be flat, nicely spread across the surface of the beaker. And then now you're going to use drops of water, room temperature water, to cover the gelatin. It's a visual process and unique to each student based on the grade of gelatin that you're using. And so you allow the gelatin to soak until softened. You can actually see the light yellow becoming brown when it's hydrated. It's a visual inspection. You add the glycerin to this once you have seen that the gelatin is hydrated. If you are working with a grade of gelatin that is different, you may have to add a little bit more water. But bear in mind, if the water exceeds and everything exceeds 85 grams, you have to evaporate water. That's a longer process. So it's best to work with a little bit of water and add a drop or two as you go along. You add the glycerin and place the beaker, the beaker with everything on the steam bath until a nice, pretty yellow solution forms. Do not stir, because if you dip a stirring device in the beaker at this time, you'll remove some of the sticky gelatin and it can affect the weight of your base. Again, if you watch some YouTube videos and in the lab, we'll show you a weighing device, a balance that has a magnetic stirrer where you drop the magnetic stirrer into the beaker so the magnets does the stirring for you, so nothing needs to leave the beaker. Unfortunately, that's not what we'll be using. Now you add the glycerin and everything dissolves. Do not stir. And once we've had a nice jelly base, you remove the container from the water bath. Moisture would be on the bottom, so you must dry the base of the beaker and place it on the top loading balance. Verify the weight. Now, this is the tricky part. Depending on the grade of gelatin you're working with, some students may have to add a little more water than some. So if you are one person who had to add a ml or two extra water here, so if the base is below 85 grams, you need to add more water to make it 85 grams. If you are one who added a little bit more water because the hydration wasn't working out for you, then use hot plate to evaporate the excess water. you have to be careful now that you do not burn the preparation. It's heat stable, so it will not destroy the preparation, but you don't want to be doing other things in the lab and it's destroyed. Everything's burnt. You don't want the burnt gelatin. Now, once you have confidently made the 85 grams, which is the weight of the beaker plus the 85 gram, there's a little wiggle room for error, but aim for accuracy. You then retrieve your zinc oxide in a very quick process without much excess aeration, because the more aggressive you stir is the more air is going to cool the gelatin and it turns gummy bear on you in your beaker. You don't want that to happen. So it's a steady stirring, a steady process. Continuously stir, nice viscous product, and then these are sample molds that you could actually pour them in. Unfortunately, we don't have these, but we're going to use the 55cc pill jars, nice cover, about quarter-inch depth, which is very nice for demonstrating this principle. So you're going to retrieve some 55cc jar pill covers, and we're going to use that as our mold. You could lubricate it with a little touch of glycerin so that the product ejects very easily. And so depending on the mold you're using, the ejection process may be difficult. We don't want to use anything outside of the formulation, so glycerin itself could be what you use, because glycerin is part of the recipe. To just swab it with the Q-tip a little bit, don't have to be a lot or excessive, so that once it is set, you can eject it quickly. And then now you just sanitize a scissors, or you can use your stainless steel spatula. And for us, we're going to cut the thing into strips, the zinc jelly into strips, and wrap them in grease paper and package them as is in a well-closed container, because again, gelatin will lose moisture and become very dry or tough to manipulate. How does the patient use this? This is the old technology. You melt it, the patient would remelt it, taking care not to burn themselves, and apply it. I think it's used for varicose vein back in the old days, but I love to use this recipe to demonstrate how we make jellies using gelatin. Now, this formulation, sodium carboxymethyl cellulose, no heat is required. And so don't get into the habit of hot water, or using water bath. No, it's not necessary. So this is where you have to look in your martingale to look at the physical chemical properties of your gelling agents. Look back at the video number 2 where we look at gelling agents. Not everything needs heat. Now, this is lubricating jelly, a basic lubricating jelly. It adds up to 100 grams, so it's not 100 milliliters. It's by weight. Jellies are made by weight. We weigh our methyl cellulose. We measure our glycerin, and of course, the density information is needed because the glycerin is very fluid, so we can convert this into a volume, and we'll measure whatever that volume is. Now, the methyl hydroxybenzoate is, do you notice how small this is? More or less, we will have to make a triturate, and that's where the solubility is needed for this, and your knowledge of making solid and liquid triturates if you are using a prescription balance where 0.1 gram was not weighable. Now, fortunately, we can weigh this in the lab using analytical balance, so we don't have to make a triturate all the time. But this is something you need to review. The patent blue is given as a stock solution. 1 ml contains 0.5 milligram of dye. That's a nice activity. Calculate the percentage weight in volume for this and see what percent is the solution. And of course, we're using freshly boiled water. Of course, the water is boiled but cool to room temperature, and that's what you're using in your preparation. Now, we make our jelly base. At all times, you're making your jelly base, and your jelly base for this is made up of water, glycerol, and sodium carboxymethyl cellulose. Now, unlike the zinc jelly lab, we're not working towards a specific weight because this formula has a lot of wiggle room. So we don't have to write down the weight of the base. That's not necessary. What you need to document is the weight of the beaker right here, the weight of the beaker, plus what the product should be, which is 100 grams, because that's what you're going to work towards. You get the beaker and disperse the sodium carboxymethyl cellulose with the glycerin to effectively wet it. This prevents the carboxymethyl cellulose from clumping on you, okay? And it also prevents it from drying out, the preparation from drying out. It's a humectant. And so when you have this now, you hydrate the jelly base with the glycerin and add small amount of water and mix vigorously, taking care not to break the beaker or exceeding the water which is allowed in the recipe. So it's a delicate dance, okay? Once you've done this, always incorporate the preservative in the jelly base. So if you need to make a triturate, you make a triturate. If you can weigh the methyl hydroxybenzoate, you dissolve it. You dissolve it according to the requirements based on the solubility. So you look in the Martindale, and here we're dissolving 100 milligrams, which is 0.1 gram. So if you need hot water, you'd have to prepare hot water. You'd have to make your solution and you add it to the beaker. And of course, whichever beaker you make your solution in, you should be rinsing it to recover all that you have dissolved. And this is what you'll also do if you are adding a soluble drug. You look at the solubility. Does it need hot water, room temperature water? You dissolve the drug, just like the methyl hydroxybenzoate here. Add it to the mixture containing everything, and you have to rinse to recover all the drug or the preservative from the beaker. That's if you did not make a triturate and you were dissolving it from scratch. Now, once you've added that to the base, you mix and allow every time you add water, the CMC is going to actually swell some more and swell some more and thicken some more. Now, if a stock solution was provided, all you have to do is to do your calculations, find out the aliquot carrying the 0.1 gram, and simply add it to your recipe, followed by the dye solution, right? And of course, again, you have to do your calculations. We need 0.001 gram of patent blue. So based on the calculation for the 1 mil has 0.5 milligrams, you have to do your calculations. So that's a little interconversion between milligram and gram. That shouldn't be too difficult for you. Once you've done this, you recover. What do you mean by recover? Recover meaning scraping all the base from the stirring device. It can be washed off with water nicely into the product, or you may have to just wipe it along the walls of the beaker to remove as much of it as possible. And then you place it on the analytical balance and add water by weight. Now, whatever is on the stirring device should not be enough to compromise the product, that when you're adding by weight, you've added a lot of water because you removed a lot of base. No, that's not the idea. It's a visual inspection. No procedure in the textbook can do this for you. It's you and the balance. You look on the steering device, you try and scrape or recover everything from the steering device, and you're adding water by weight. All right. Now somebody could say, could we not calculate the water we need? You'd have to know the density of everything in the formulation or the weight. And so the methyl hydroxybenzoate, the patent blue, if you know the density of the solution, you can always convert them into grams and calculate the grams of water to be added. And then in that case, you can weigh your gram of water. 1 gram of water is equal to 1 mil. Now, of course, you can pre-calculate your water, because for really very dilute solutions, we treat 1 gram as 1 mil. So depending on the density so look at glycerol. Glycerol is very thick. 1 gram of water is not equal to 1 mil. And so you needed the density information for glycerol if you're going to measure it. For dilute solutions like the patent blue, which is very dilute, you could treat 1 gram as 1 mil. So yes, you can look at the recipe and calculate the water you're to add, but the principle of semi-solid is that you're adding here QS to 100 gram, which means you're doing it on the balance. So this is being made by weight, and that's a principle we're emphasizing with jellies. The last one that we're going to look at, so this is a little longer video than usual, is tragacanth jelly. Last one on the recording. Tragacanth formulation, also taken from one of the reference book. We're adding ichthymol, a viscous drug, as the active ingredient. So unlike the parabens where you're dissolving the preservative, a possibly soluble drug or a soluble preservative, this one you're adding something very thick. And so if you pre-weigh the ichthymol in a separate container, it's not likely that you'll be able to remove the 2 gram from the container. So again, this is made by weight. What do we mean by weight? You record the weight of the beaker and of course the packaging jar. You're going to make the jelly base using the tragacanth, alcohol, and glycerol. Mix all 3 of these in a container. Once you do that, you add some water to make it a little bit more fluid, right? Recover all the contents from the stirring device and place the beaker on the balance. When you do that, you zero or tear the balance and then drop wise using just put some ichthymol in a beaker, and you can use a glass stirring rod. Dip the stirring rod in and place it over the beaker with the tragacanth, alcohol, and glycerol that you have tiered. You have to zero the balance for this. You then add the ichthymol drop wise, 1 drop at a time, and allow the balance to respond so that you don't exceed the 2 gram. Now, to me, this is a better technique than to weigh 2 grams of ichthymol in a separate container, right? There's something you could also do. You could also weigh the ichthymol in a container in a separate beaker of known weight. Make your jelly base as much as possible in a separate beaker and transfer it into the ichthymol and stir. If you do this, you still have to recover everything from the stirring device. You have to scrape all the tragacanth and the glycerin, but it's more runny. It's better to scrape that from a container than the ichthymol from a container, because the tragacanth mixture would not be very clumpy and thick like the ichthymol. You can transfer it to the pre-made, pre-weighed ichthymol and then make that up to weight. So it's your choice if you want to weigh the 2 gram of ichthymol in a glass beaker and then make the tragacanth jelly in a separate beaker and transfer it onto the ichthymol, recover as much as possible and then add up to weight. That's your choice. Or you can make the tragacanth base in a beaker and then add the ichthymol to it drop wise by weight. To me, it's a matter of the technique that gives you less error, right? Your textbook just simply said add ichthymol. It doesn't tell you how. And so that's the technique I'm sharing in this video. So with that said, I've shared with you 3 jelly formulation using 3 different gelling agents. And so I hope that this content will help to ease your anxieties the next time you try to make a jelly in your lab. Thank you for watching this video. Don't forget to subscribe, like, and comment, and even share to somebody who you know would like this content. Thank you.